Hello, guys! Welcome! We are going to continue learning about ways in which we can study the ocean floor. Yeah! Okay, so yesterday we learned about sonar, which we know is when sound waves travel deep into the ocean water and they hit the surface of the land of the ocean and comes back. So it rebounds after hitting the land. As you can see in this image right here, if this was sonar mapping, what would happen is they would emit a sound wave, it would travel lower and lower, deeper and deeper into the ocean, hit the surface of the land, and then that is the moment when you can tell what it looks like and how deep it is. And that's what sonar is. Now, the another word for sonar is actually sound echoing or echo sounding. Sorry, it was not sound echoing, that was my bad, but it is echo sounding because it focuses on the echo that occurs after the sound waves travel from whatever source you're using. If you're talking about ships, then those. Now, if you guys remember, we have something called, of course, sonar is not the only way we can study the ocean, right? There were two more. We study about satellites that are high above the surface of the earth, and we have submersibles that are really travel deep into the surface and go deep into the ocean and study life in the ocean, study what it looks like, what minerals there are, so all these different things that they study. So the picture here, as you can see, since it is deep into the ocean, which can be seen by the water bubbles right here as well, we can imagine that this is actually a submersible and not an airplane. All right, now let's move on to the question we all want the answers to. Why is the ocean salty? Why can't we drink it even though like over 70% of Earth is filled with oceans? Why is it not drinkable? Well, the answer is literally salt. But not just salt. I'll explain what I mean. So there's a term for saying how much amount of salt is there in every unit of water. And this term is called salinity. Salinity. Now, when we test the water in the ocean, you would see that the most common and the most abundant salt in seawater is NaCl, sodium chloride. But there are also other forms of salt that are present in the form of ions. Now, NaCl is also known as the common salt. So that is another term that you guys can remember, the common salt. That's what's present abundantly in the oceans. But here's the deal. It's not the same everywhere. So in the North Pole and in the South Pole and the equator, you will see that salinity is very different. Now, when we are talking about the equator, which means the center of the earth, where the sun has the strongest rays, where the sun's strongest rays of light hits, the salinity here is actually lower than average compared to if you were talking about the Mediterranean Sea, for example. So in the equator, the salinity is lower than average, but the reason is because of greater precipitation. Does anyone remember what the term precipitation means? It's okay, take a minute, I'm right here. I'll give you guys a hint. It has something to do with the water cycle. Well, if you guessed precipitation is when water particles come down to the surface of the earth from the atmosphere, you are absolutely correct. Precipitation can be in the form of, rain. It can also be in the form of snow or sleet. But if you're talking about the equator, it's more probable that you're talking about rain because it's warmer here. Now, on the other hand, when we go closer and closer towards the poles, the top of the Earth or the bottom of the Earth, the salinity is once again lower than average, but that is due to the melting sea ice. What that means is because of global warming, the ice caps are melting. And when this happens, new fresh water is being continuously introduced to the ocean. And as a result of that, we can say that the salinity near the poles is going to be lower than average. Now, let's talk about the Mediterranean Sea. Here, the salinity is actually higher than average. The main reason being evaporation. Now, evaporation, once again, is a part of the water cycle. Can you guess which part? Well, if you guess that evaporation is a process where the water from liquid state turns into gaseous and dissolves into the air, you are absolutely right. In the form of water vapor, the water leaves the surface. So when that happens, all that's left is the salt that's getting more and more concentrated, as a result of which the salinity here gets higher than the rest. As simple as that. Now let's move on to the next slide. Where does the salt come from? Well, there are different sources for the salt. It can come from chemicals that eventually eroded from the Earth's crust and washed into the sea. It can come from the volcanoes. When volcanoes erupt and there are solid or gaseous ejections, these particles get swept into the winds and eventually get dissolved in the ocean, and they get dissolved and then they get deposited on the ocean floor. And these are all chemicals that change the fundamental structure of the ocean. So this is one of the reasons where the salt comes from. Now, one more thing that I do want to let you guys know is that as surface water washes over rocks, right? And if those rocks contain salt, when the surface water once again goes back into the sea or into the ocean, it's taking that salt with it, right? So it's gonna take that common salt with it when it hits the ocean, when it hits the beach, for example, and hits a rock which has salt. So these are all different sources from which it's getting its salt. Now you might be wondering why does a seawater look very colorful? Well, the reason being the depth. If there's a difference in depth, they're going to have a different color. Now you might be wondering, why does a shrimp appear bright red at the surface but very, very black when you go deeper and deeper? And why is this useful? Well, it has something to do with physics. See, we have different wavelengths of light. If you guys remember the colors of the rainbow, those are the different wavelengths. And the color red are longer and are absorbed before reaching the deep water more. So if the red color is taken away, all that's left is the darker color. But this is beneficial because the shrimps can now hide and not become a meal. I hope this made sense to you all. If you have any questions, once again, reach out to me and let me know, and I'm here for you guys all the time. And here are the answers to today's guided notes. I hope you guys have a great day, and I will see you guys later. Bye!